Hey guys, what's up? Welcome back to my channel. So today we are back with part 3 of chemical reaction and equation class 10. So let's start without wasting any time, and if you haven't seen the first and second part, do check them, because if you don't see them then you won't be able to understand this nicely. So let's begin and let's start from beginning. So welcome back. Yes, you all were missed. So let's go ahead. Topics we will cover today. So topics we will be covering today would be types of chemical reactions, second corrosion, okay, and also rancidity, and also how to prevent them. So let's start. So class in chemical reaction and equation, types of chemical reaction. So as we had learned about chemical reactions before, we must be knowing that there must be some types also of chemical reaction. So we will check them also. Let's begin. Okay. So first one is combination reaction. Second is decomposition reaction. Third is single displacement reaction. Fourth is double displacement reaction. And fifth is redox reaction. So let's ignore the sound in the background, please. Let's go. Combination reaction. So from the name you can see that something is going to be combined over here. So we can see that the definition says that a reaction in which two or more elements or compounds combine to form a new substance is called combination reaction. As I told you that the things were being combined over here. Okay, so let's go ahead with the second one. Addition of two elements or compounds to form a new substance. So this is a short definition for this. Addition of two elements or compounds to form a new substance. It would be a short definition for combination reaction. And let's see that how combination reaction can be represented. So it can be represented as A plus B, which will give rise to AB. For example, I'm telling you H2 plus O2 gives rise to H2O. Okay, so examples of combination reaction. So examples of combination, please ignore the sound. Examples of combination reaction are, my English accent is quite good actually. I don't know, that's quite good. So combustion of coal, the first one, combustion of coal. Coal, carbon burns in excess of air, oxygen to form carbon dioxide. So it must be C plus O2. Carbon is solid, O2 is gas, CO2 is gas. So carbon plus oxygen give rise to CO2, which is carbon dioxide. Formation of given hydrogen chloride. Hydrogen chloride, remember the formula? HCl. When a mixture of hydrogen and chlorine is exposed in sunlight, it results in the formation of hydrogen chloride gas. So H2 plus Cl2, 2HCl. Okay, let's go. And next slide. So, synthesis of ammonia. When the molecules of nitrogen gas combine with three molecules of hydrogen gas. See, molecules of nitrogen gas combine with three molecules of hydrogen gas. So, it would be N2 plus 3H2, because there are three, okay. So, it would come as the reactants on the left hand side. Then, ammonia is obtained. Then, as you can see, the formula for ammonia is 2NH3. Let's go to our fourth one, example. Formation of sulfur dioxide. So this is the easy, very common. When sulfur is heated in air, oxygen, then sulfur dioxide is formed. If you just heat sulfur in air, then the sulfur dioxide would be formed. The equation for this would be S8 plus 8O2, which will give rise to 8SO2. Formation of iron sulfide. So when iron brown black is heated with sulfur powder, yellow iron sulfide black is formed. Okay, so iron is a what? Of brown or black color mostly, and is heated with sulfur powder, which is actually yellow. Then iron sulfide black is formed. 8Fe plus S8, which will give rise to 8FeS. Okay, now let's go to some easy examples for this, so that you can remember it nicely. Okay, easy. Formation of nitrogen dioxide. When nitric acid, which is actually colorless, and oxygen, which is also colorless, they both combine, they form reddish brown colored nitrogen dioxide gas. And you can also see that nitrogen dioxide gas, you can find it in chips packets or something like that. So let's see this. So 2NO plus O2, which will give rise to 2NO2. Combination of hydrogen and oxygen, it was water. See, hydrogen burns in oxygen to form water, so it would be 2H2 plus O2, H2O, 2H2O. It's balanced actually, the chemical equation over here. So let's go ahead. Decomposition reaction. So some, for a easier definition for this, it is the opposite of combination reaction. In combination reaction, what we saw, two molecules were combining to form a new substance. But in decomposition reaction, the wait, see, in decomposition reaction, It is the actually the reaction see, this is the definition. Those reaction in which a single substance in combination, what we saw, that two substances combine to form a new one. Here one substance breaks into two or more simpler. So here see, those reaction in which a single substance breaks up to give two or more simpler substances are called decomposition reaction. Okay, it can be represented as AB, which will form A plus B. Okay, let's go ahead. Types of decomposition reaction. There are actually three types of decomposition reactions. I will tell you a short trick to learn it. Okay. Thermal decomposition, electrolytic decomposition, and photochemical decomposition. Now just see, it said PET, PET. Photochemical decomposition, electrolytic decomposition, thermal decomposition. Thermal decomposition is the decomposition of a substance caused by heating. Okay, decomposition of a substance caused by heating is called thermal decomposition. And in a simpler, we can say that the breakdown of any molecule when heat is used, or decomposition because of heat. Now let's see the example. Okay, for decomposition of calcium carbonate. So calcium carbonate on heating decomposes to give calcium oxide and carbon dioxide. So carbon dioxide, we know it's the CO2, yes, CO2, and calcium carbonate is what? CaCO3, which will be heated and it will form calcium carbonate, and it will become that calcium oxide plus carbon dioxide, CaO plus CO2. Second, decomposition of hydrogen peroxide. On heating, hydrogen peroxide decomposes into water and oxygen. 2H2O, to heat it, then we get it as 2H2O plus O2. Let's see electrolytic decomposition. So as in thermal we saw it was done by heat, here it is done by electric current, agency of electric current. So decomposition of a substance by the agency of an electric current is called electrolytic decomposition or electrolysis. So the breakdown of any molecule when electricity is used, or decomposition because of electricity, electric current. Now let's see example for this. See, 2H2O, which is actually liquid, will give rise to 2H2 plus O2, which are gas. So the water gets decomposed due to the passage of electric current, producing hydrogen and oxygen gas. Okay, so let's go to our third topic, which is photochemical PET, P. Okay, P of PET. So decomposition reaction may also be brought by the agency of light. Such a reaction is called a photochemical reaction. Here, like in first two, we saw because of heat, because of electric current, agency of electric current. Here, because agency of light. So the breakdown of any molecule when light is used, or decomposition because of light, which is mostly sunlight. So example is when 2AgBr gives rise to 2Ag plus Br. So here 2AgBr is what? Silver bromide, and 2Ag is silver, and Br is bromine, where silver bromide is S, and 2Ag is silver, which is solid only, and Br, which is gas, we know that. So let's go to our third topic and third type of reaction, which is displacement reaction. So the reaction in which one atom or a group of atoms, called radicals of a compound, is replaced by another atom or radical, are called single displacement or simply displacement reactions. So displacement reaction are also known as substitution reaction, a type of chemical reaction in which an element is replaced by another element in a compound. Okay, in a simpler way, a type of chemical reaction in which an element is replaced by another element in a compound. So here also, displacement reaction, you can say that a chemical reaction in which a more reactive element displaces a less reactive element from its compound. Okay, now this reaction can be generalized as A plus BC and B plus AC. Okay, let's go to some examples of check some examples of displacement reaction. So the first one is, wait one second, uh, chlorine displaces bromine from a bromide solution. So bromide solution, we knew what it was, and chlorine. So just you tell me, I'm not going to show you the slide. What will be for chlorine? So we know that for chlorine it will be what? Cl2, and for potassium bromide, 2kBr, which will give rise to potassium chloride. Potassium chloride is easy, we know KCl, like HCl is hydrogen chloride, KCl is potassium chloride, plus Br2, which is bromine. Let's go ahead. Okay, this is also of two. actually they're decreasing reactivity. Okay, so in this also you can see that potassium is the most reactive and platinum is the least reactive, and the sodium, calcium, magnesium, aluminum, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum, these are all going from most reactive to the least reactive. All right, so let's go ahead. Okay, so double displacement reaction. In this type of reaction, it is also like, in this also we can see the exchange in this. Okay, I'm telling you first exchange. So those reaction in which anions and cations of two different molecules switch places, forming two entirely different compounds, are called double displacement reactions. Okay, here there is exchange of ionic compounds. When a part of two ionic compound is exchanged and make two new components, then it is known as double displacement reaction. Those in which two chemical substances react by exchanging ions to produce two new molecules, and those reactions in which the positive and negative ions of two ionic compounds exchange places to form two new compounds. So, exchange of ions or reactants. These were some simple for you to remember, simple points. So, bullet points actually. So, let's see. The double displacement reaction generally takes the form of AB plus CD and AD plus CB. Okay, so here we can see where A and C are positively charged cations, and while B and D are negatively charged ions. So now let's see some types of double displacement reaction. It is of two types: precipitation reaction and neutralization reaction. So precipitation reaction is a chemical reaction occurring in an aqueous solution where two ionic bonds combine, resulting in the formation of an insoluble salt. Then this type of reaction is known as precipitation reaction. Okay, and an insoluble solid that emerges from a liquid solution, or precipitation is a form of a solid. Okay, let me tell the meaning of precipitation. So it is a formation of a solid in a solution during a chemical reaction. So a reaction in which an insoluble solid known as precipitate is formed is called a precipitation reaction. Now let's see some examples of precipitation reaction. So precipitation of silver chloride as a white precipitate, PPT, when aqueous solution of silver nitrate and sodium chloride are mixed together. So AgNO3 was what? Silver nitrate plus NaCl, we all know, common salt or sodium chloride, which will give rise to what? AgCl, which is silver chloride. You can see Ag plus Ag and Cl is the silver and chloride, plus NaNO3. Na is what? Sodium, and NO3 is nitrate, so sodium nitrate. Let's go to our next topic, which is neutralization reaction. So in neutralization reaction also, it's not anything another thing. It is just the reaction of an acid and base to form salt and water. So here in a simple way you can say that here also, if you do A plus B, then it shall form NaCl plus H2O. Okay, acid plus base shall form salt plus water. Some example of this is when aqueous solution of sodium hydroxide and hydrochloric acid are mixed together, sodium chloride and water is formed due to exchange of ions. So NaOH plus HCl, okay, sodium hydroxide NaOH and HCl, we all know, hydrochloric acid, which will form NaCl plus H2O, like water plus salt. Okay, now let's go to our fifth topic, redox reaction. This is quite important, so please put your mind in this nicely. So a reaction in which oxidation and reduction take place simultaneously is known as a redox reaction. So oxidation and reduction meaning we will see now. First let's see some example. So CuO plus H2 will give rise to Cu plus H2O, copper plus water. Okay, and there are two types of redox reaction, as I told you, oxidation and reduction. So here oxidation means if a substance gains oxygen or loses hydrogen during a reaction, the substance is said to be oxidized, and the process is called oxidation. In a short way, it can be written as addition of oxygen, which is O2, and removal of hydrogen. Example, copper plus O2, which is oxygen, when it is heated, then it forms 2CuO. Okay, next, let's get to our next topic, which is reduction. So reduction, if a substance loses oxygen and gains hydrogen. In oxidation, what we saw, that actually oxygen was gained and hydrogen was released. Here we can see if a substance loses, here in reduction oxygen is loosed, it is reducted, and it gains hydrogen. Here hydrogen is gained during a reaction. Then the substance is said The product is called reduction. So let's read it again. If a substance loses oxygen, wait, let me show you a simple point for this, a bullet point, which is usually used. So addition of hydrogen, removal of oxygen. So let's see some example. So CuO plus H2, this will give rise to Cu plus H2O. Again, here also we can see copper plus water is formed outside. Now let's see one of the main reaction which is like usually arcs. So it is none other than exothermic. 3 2 exothermic reaction. So in this reaction also heat is released. Like I also know this, it is really, the topics of this chapter is not so hard to remember, it's easy, because that chemical reaction in which the heat is released along with the formation of product are called exothermic reaction. In this type of reaction heat is released, okay, and heat release. See, an example is burning of candle, reaction of strong acid with water, calcium oxide plus water which will form calcium hydroxide, the sheet, then C plus. Okay, next, endothermic reaction, which is one of the main topic after. So this is the opposite of exothermic reaction. Here in exothermic we saw heat was released, and in endothermic, the heat is absorbed along with the formation of product are called endothermic reaction. Those reactions in which the heat is absorbed along with the formation of product are called endothermic reaction. So here also heat is absorbed. Example would be N2 plus O2 plus heat, which is 1 2 NO, Ca calcium carbonate plus heat, CaO plus CO2, which will be again calcium oxide plus carbon dioxide. Now, last topic, the second last topic, corrosion. So meaning of this would be, it is like deuterization of metals by action of air, moisture, chemicals, etc. Deuterization of metals by action of air, moisture, chemicals, etc. Or process of slow conversion of metals into their undesirable compounds by the action of components of air, oxygen, moisture, and other gases like SO2, NO2, CO2, H2S. An acid is known as corrosion. So in a short way, you can just say that deuterization of metals by action of air, moisture, chemicals, etc. So let's see example of this. So rusting of iron first, tarnishing of silver, then tarnishing of copper, then rusting of stainless steel. Okay, now let's see how to prevent this corrosion from happening. So first we can do painting. We can just paint the iron articles. Okay. Second we can do oiling and greasing. I will also tell you a short way to remember these. I will tell you. So oiling and greasing, the machine parts, and third is galvanization. So galvanization, you must be not knowing the meaning. I will show you right now, but let me just confirm before showing you. It is a type of zinc coating on iron or steel to prevent rusting. It is like zinc coating on iron or steel to prevent rusting. See, as I just told you, it is written zinc coating on iron or steel to prevent rusting. To remember this, you can just say that POGG, POG, where you can see painting, oiling, greasing, and galvanization. Let's go into our last topic, which is rancidity. So, rancidity first comes from a Latin word which is ranidus. Okay, the word rancid comes out from a Latin word ranidus, which means having unpleasant smell or taste. Okay, slow oxidation of oil and fat. In a short way, we can say rancidity, that's slow oxidation of oil and fat. In this type of reaction, there is spoiled food which we cannot consume. Okay, it is spoiling the food material which is difficult to consume. Let's see some prevention now for acidity. So addition of antioxidants to food. Okay, then storing the food in airtight containers. So I'm giving you example from myself. You must have seen in your house that your mother keeps the things in airtight containers. Like for example, if there is chips in your house, then she will keep in airtight containers so that they don't get bad, or they don't get like too much light actually. So storing the food in airtight containers, which prevents them from rancidity, because if it comes in air contact with air, it will start becoming in a bad way. So third is by keeping the food items at low temperature and storing the food in refrigerator. You must have kept the food from last night also many times to prevent. You can't just keep it out, right? Actually, so then vacuum packing, and the last one, replacing air by nitrogen. So you must have seen that we replace air often with nitrogen in potato chips or something. So thank you so much for watching. The chapter ends here, and bye bye.